Okay, today I will be attempting to do this one-handed, so bear with me. The domain, I'm not sure how to find that without first knowing the vertical asymptotes, because I'm pretty sure it's not all real numbers. The x-intercepts is any time that the top equals 0, the numerator. So, let me factor this out. God, this is really awkward. Okay. You have a factor of 8 would be 2 and 4. And for them to add to -2, you could have x plus 2, x minus 4. So to set either of those to 0, you're just going to want to do the opposite number. So there's going to be an x-intercept at -2, 0, and at 4, 0. Okay, y-intercepts, you set all of the x's equal to 0. So it's just going to end up being -8/1, because those are the only variables that don't have a 0. So it's just going to be 0, -8. Okay, the vertical asymptotes are whenever the denominator equals 0. So to get this denominator equal to 0, it would just have to be -1. So x equals -1. To do the slant asymptote, I'm going to have to divide this out. So alright, and then x on the top, x times x is x squared, x times 1 is x, subtract that, -3x minus 8. Okay, so to get rid of that -3, you need to do a -3 right there, -3x minus 3. And that is going to be -5. So there's a remainder of -5. But for the slant asymptotes, you don't worry about the remainder. You just worry about this part right there. So the slant asymptote is going to be y equals to x minus 3. Okay, end behavior. This is an improper rational function, and the leading coefficients are 1 and 1. So that's just going to be 1. So the end behavior is going to be as x goes to infinity, f of x goes to 1. As x goes to -infinity, f of x goes to 1. Alright, and now that I know the vertical asymptotes, that means that x will never touch -1. I can do the domain. So x is greater than -1 or less than -1 for the domain. But it's never equal to -1. So all real numbers except for -1. Okay, looking good so far. For this, I'm going to put 0 at the middle. For my x-intercepts, it's going to be -2 and 4. and my vertical asymptote is at -1. Alright, just let me set you down for 1 sec. Okay, so we've got an asymptote at -1. And you've got a horizontal or oblique asymptote at y equals x minus 3. Okay, so there are the asymptotes. The x-intercepts are going to be -2, 0 and 4, 0. And the y-intercept is -8. So, let's start figuring this out. So let's do less than -2 first. So let's do -3. So if I plug -3 into the equation, okay, so that's basically just going to be -5 over -2, simplified down, and that's just going to be 5 over 2, or 2 1/2 at -3. Wait a second, I think I did that wrong. Okay, so -3 squared is 9. Okay, now I see what I did. Okay, minus 2 times -3 minus 8 over -3 plus 1. So that's just going to be 9 plus 6 minus 8 over -2. Which is going to be 15 minus 8 is 7 over -2. So -7 over 2, or 3 1/2, -3 1/2. So, erasing this point I screwed up. Alright, so it's negative there. So it's negative after that. Let's do -1.5 and plug that in. It's -1.5 squared minus 2 times 1.5 minus 8, 1.5 plus 1. Okay, I'm gonna do 1 second. Okay. So negative 2.25 plus 3 minus 8, or negative 0.5. Okay, so that's going to be negative 7.25 over 1 second. God. Oh, I hate this. Okay, so negative 7.25 over negative 0.5. Or basically, 14.5. Okay, so that's not on the graph, but it's like somewhere up there. So we know this line okay, so this section's positive right here, and there's that line so far. Okay, now let's just do 0.5 or negative, yeah, no, just 0.5. Okay, so 0.5 squared minus okay, so that's 0.25 minus 1 minus 8 over 1.5. I don't know if you're even seeing any of this, but I'm trying, so. Okay. So either way, that's going to be negative 8.75. It's going to be right there. So that means that this line is negative right there. Okay. And then there's no way it can go positive without crossing the asymptote before it reaches this next x-intercept. So we already know that this next part is negative. So I'm just going to draw that line so far. Okay, so this is what we have right now. Now I need to find a number greater than 4, so I'm going to do 5. Squared minus So that's going to be 7 over 6, which is 1 1/6 out of 5. Okay, so that's positive. So that means if it's at 7/6, it's going to be like right there. And we're just going to be getting closer and closer to that asymptote forever. So this is my finished graph. You can pause it here to check my work if you would like. Again, this is Jacob Strong, and I'm done.